Hello all, today we are going to do the experiment specific rotation and polarimeter. Aim of the experiment is to determine the specific rotation of sugar solution by using a polarimeter. Now we can come to the theory part.
First of all, we want to know about the polarimeter, which is an integral part of this experiment. A polarimeter is an optical instrument to measure the angle of rotation of the optically substance in liquid medium by which the polarization of light is rotated. The angle by which the polarization plane is rotated is called optical rotation. Coming to optical rotation, normal monochromatic light consists light that possesses oscillation of the electrical field in all possible plane perpendicular to the direction of propagation. When light is passed through a polarizer, that is nickel prism, Polaroid film, only light oscillating in one plane will leave the polarizer. A polarizing film transmits only light in a certain polarization direction and suppresses the light of other polarization directions. Light which has passed through a polarizing filter is called polarized light. The general equation for specific rotation is specific rotation of wavelength equal to 100 into observed rotation in degree divided by path length into concentration. Coming to the parts of polarimeter, first of all its light source, next is polarizer which is fixed which cannot be rotated. Next one is polarimeter tube. Polarimeter tube contains an optically active substance in a solution which causes the plane of polarized light to rotate. Next is analyzer, a rotatable polarizer. This lens is rotated until no light goes through the second lens. The angle is then measured to determine the optical rotation of the solution.
Let us record our polarimeter, polarimeter tube, sugar, weighing machine, measuring jar and beaker, and distilled water. Now, coming to the initial adjustments. Switch on the monochromatic light source and the polarimeter should be kept in such a way that it should be close to the source of light. First of all, we are going to find the least count of the polarimeter. As we know, the least count, the equation is 1 main scale division by total number of vernier scale division. As we can see here, this is the main scale division and this is the vernier scale division. So here 1 MSD is 1 degree and the VSD is 10. Value of 1 division of main scale is 1 degree and the number of division of the vernier scale is 10. So the least count will be 1 by 10 which is equal to 0.1 degree.
Here we have two tabular columns. One is for taking the readings, MSR reading, VSR reading and total reading, and the next one is for finding the optical rotation. At first, we are going to find the concentration of sugar solution at 0 and that will be R0 and it is a reference value. After that, we will be taking for different concentration of sugar solution, that is 0.4, 0.35, 0.30, 0.25, 0.2.
First of all, we have to clean the polarimeter tube with water so that if there is any dust particles inside it, it will be removed. Okay, now we have cleaned the polarimeter tube with water and we have filled it distilled water. If there is any bubble inside it, it should be minimal and it should be at the center. Now we are going to keep the polarimeter tube inside the polarimeter. Now inside the polarimeter, we have the polarimeter tube filled with distilled water. After that, we are going to observe through the eyepiece and find the R0 value. Two halves of unequal intensity. This is not what we actually want to observe. We want to see two halves of the field intensity to be equally bright or equally dark. We can see here both the halves are changing from equal to unequal intensities. Now, after viewing full shade, we are observing the main scale value. Here, the main scale value is 107 degree. So, the main scale reading will be 107. Coming to the VSD reading, here it is 2. So, the total reading will be MSR plus VSR into LC. The LC here is 0.1 degree. So, the R0 value will be 107.2. Now, we have got the R0 value. After this, we are going to find the R values for different concentration of sugar solutions. Now, we have took 10 gram of sugar and 25 ml of water. As you can see, now we are going to dissolve the sugar in the distilled water. So that we have got 0.4% of sugar solution. We are filling the polarimeter tube with the sugar solution. At present, we have the polarimeter tube filled with 0.4 gram per centimeter cube. And now we are going to keep this inside the polarimeter. Like we observed the R0 value for distilled water, the same we are going to do for the sugar solution. The full shade have been observed for 0.4% of sugar solution and the main scale reading is 167 and the vernier scale division is 2. Now we can note down these values. So the main scale division is 167 and the vernier scale reading is 2. So the total reading will be 167.2 moving to 0.35%. We have found the R values for different sugar solutions such as for 0.35, 0.30, 0.25 and 0.2 and the optical rotation alpha is found out by the equation R minus R0 for each sugar solution.
Okay, now we can plot the graph, and here in graph x-axis we are taking concentration which is in the unit gram per centimeter cube, and in y-axis alpha which is optical rotation which is in the degree unit, and slope is therefore delta alpha by delta c.
Now coming to the calculation part, the equation provided here is specific rotation is equal to slope into 1 by L, where L is the length of the polarimeter, which we have found out that L is equal to 2.1 decimeter. Now the slope from the graph we have found out that it is 157.89 gram inverse centimeter cube. Now we will substitute these values in the equation provided. So the specific rotation will be 157.89 by 2.1, that is 75.18 degree decimeter inverse centimeter cube gram inverse. So now coming to the result part, we have found out that the specific rotation of sugar solution by using polarimeter, from the calculation we have got 75.18 degree decimeter inverse centimeter cube gram.